For centuries, the vast and mysterious cosmos has been a source of fascination and intrigue for humanity. Among the many celestial events that have captivated our imagination is the predicted collision between our home galaxy, the Milky Way, and our neighboring giant, the Andromeda galaxy. This colossal event, forecasted to take place in about 5 billion years, has long been considered inevitable, a cosmic dance that would culminate in the formation of a new, merged galaxy. However, recent research has introduced significant uncertainty into this narrative, suggesting that the fate of our galaxy may not be as clear-cut as once thought. The classic narrative, an inevitable collision. The idea that the Milky Way and Andromeda are on a collision course dates back over a century. In 1912, astronomers first observed that Andromeda, also known as Messier 31, is moving towards us at a staggering speed of approximately 110 kilometers per second, 68 miles per second. Given the gravitational forces at play and the relative motion of the two galaxies, it was concluded that they would inevitably collide, eventually merging into a single, larger galaxy. This impending collision has been depicted as a dramatic event that would reshape the structure of our universe on a grand scale. Stars, planets, and other cosmic bodies from both galaxies would be thrown into new orbits, with some being ejected into intergalactic space. The Milky Way and Andromeda would slowly spiral towards each other, their mutual gravitational attraction pulling them closer until they finally merge into a new, elliptical galaxy, a process that would unfold over billions of years. Astronomers have even named this future galaxy Milkomeda, a hybrid name reflecting the union of the Milky Way and Andromeda. The thought of our galaxy being absorbed into a new entity, along with the possible cataclysmic consequences for our solar system, has sparked both awe and fear in the minds of many. New simulations, new perspectives. However, the latest research has significantly altered our understanding of this cosmic event. In a groundbreaking study led by Till Sawala from the University of Helsinki, astronomers employed advanced simulations that take into account a broader range of variables than previous models. These simulations incorporated not only the gravitational interactions between the Milky Way and Andromeda, but also the influences of other nearby galaxies within the local group, such as the Large Magellanic Cloud and the Triangulum Galaxy, M33. The findings of this study are nothing short of revolutionary. Instead of a guaranteed collision, the simulations suggest that there is now only a 50% chance that the Milky Way and Andromeda will collide within the next 10 billion years. This represents a dramatic shift from earlier predictions, introducing a level of uncertainty that has profound implications for our understanding of galactic dynamics. The study highlights the importance of smaller, yet still significant galaxies in the local group. The Large Magellanic Cloud, a satellite galaxy of the Milky Way, and the Triangulum Galaxy, which orbits Andromeda, exert gravitational forces that could potentially alter the trajectories of the two larger galaxies. These forces might be strong enough to prevent a direct collision, leading instead to a near miss, where the galaxies pass by each other without merging. This potential scenario would have its own dramatic consequences. As the galaxies approach each other, the gravitational forces could disrupt their outer regions, stripping stars and other celestial bodies from their orbits and flinging them into intergalactic space. While the cores of the Milky Way and Andromeda might remain largely intact, the outer regions could be left in disarray, creating a cosmic spectacle of stellar debris and newly formed star clusters. The role of the Gaia and Hubble Space Telescopes. The data underpinning these new simulations were gathered using some of the most advanced observational tools available to astronomers today. The European Space Agency's Gaia mission and NASA's Hubble Space Telescope have provided incredibly precise measurements of the positions, motions, and masses of stars within the Milky Way and Andromeda. These observations have been crucial in refining our understanding of the dynamics of these galaxies and the forces that govern their movements. Gaia, in particular, has been instrumental in creating the most detailed map of the Milky Way ever produced. By tracking the motions of over 1 billion stars, Gaia has allowed astronomers to build a highly accurate model of the Milky Way structure and its interactions with neighboring galaxies. This data has been vital in updating the simulations that predict the future of the Milky Way and Andromeda. Hubble, on the other hand, has provided a wealth of data on the movements of stars within Andromeda, helping to refine estimates of the galaxy's trajectory. By combining data from both telescopes, astronomers have been able to create simulations that are far more accurate than anything that came before, leading to the surprising conclusion that a collision is not as certain as once believed. Implications for the solar system. One of the most pressing questions surrounding the potential collision between the Milky Way and Andromeda is what it would mean for our solar system. In the classic scenario where the two galaxies collide and merge, the solar system would likely be displaced from its current position in the Milky Way's spiral arm. Depending on the exact dynamics of the merger, the Sun and its planets could end up much farther from the center of the new galaxy, in one of its outer regions. However, even in the event of a direct collision, the solar system would probably remain largely unaffected in terms of its internal structure. The vast distances between stars mean that actual star collisions are exceedingly rare, even during a galactic merger. Instead, the solar system might simply be relocated within the new galaxy, continuing its journey through the cosmos with minimal disruption. If the galaxies do not collide, but instead pass by each other, the solar system could still experience some changes. The gravitational forces at play during such a close encounter could alter the orbit of the solar system within the Milky Way, potentially moving it to a different part of the galaxy. While this would be a significant event on a cosmic scale, it would likely have little direct impact on life on Earth. The broader cosmic context, the potential collision between the Milky Way and Andromeda, is just one chapter in the larger story of the universe's evolution. Galactic collisions are not uncommon. In fact, they are a key mechanism through which galaxies grow and evolve over time. Our own galaxy has already experienced several mergers with smaller galaxies in the past, and remnants of these events can still be seen in the form of star streams and other features in the Milky Way's halo. Understanding the dynamics of galactic collisions is crucial for astronomers as they seek to unravel the history of the universe. These events provide insights into the processes that drive galaxy formation and evolution, helping to explain the diversity of galaxy shapes and sizes we see today. The study of the Milky Way-Andromeda interaction is, therefore, not just about predicting the future of our galaxy, but also about understanding the forces that have shaped the universe as a whole. The ultimate fate of the universe. While the possible collision between the Milky Way and Andromeda is a fascinating topic, it is just one part of the broader narrative of the universe's future. In the very long term, the universe is expected to continue expanding at an accelerating rate, driven by the mysterious force known as dark energy. As this expansion continues, galaxies that are currently close to each other will eventually drift apart, becoming isolated in an ever-expanding cosmos. In this distant future, billions of years after any potential merger between the Milky Way and Andromeda, the newly formed galaxy, if it exists, might find itself alone in the universe, with all other galaxies too far away to be observed. This island universe scenario is the ultimate fate of galaxies in a universe dominated by dark energy, a reminder of the impermanence of cosmic structures. Conclusion: a cosmic puzzle. The question of whether the Milky Way and Andromeda will collide is a complex one, with new research suggesting that the answer is far from certain. The latest simulations indicate that the future of our galaxy is much more uncertain than previously thought, with the possibility of a collision now reduced to a coin flip. This new understanding challenges long-held assumptions and highlights the dynamic and unpredictable nature of the cosmos. As we continue to gather more data and refine our models, our understanding of the universe will undoubtedly evolve. For now, the Milky Way and Andromeda remain on a potential collision course, but the exact outcome is still up in the air. Whether they merge, pass by each other, or something entirely unexpected happens, one thing is certain: the universe will continue to surprise and amaze us with its complexity and beauty. This deep dive into the fate of our galaxy serves as a reminder of the vastness of the cosmos and the incredible forces that shape it. As we gaze up at the night sky, we are witnessing the unfolding of a story billions of years in the making. A story that, in many ways, is just beginning.